Good morning. I just wanted to talk about some important things related to the next chapter. This chapter is the foundation for about 6 or 7 more chapters to come. And therefore, it's very important that you really understand the vocabulary used in this chapter. And basically, you have to read the text, watch my lecture video to understand these terms that I'm writing down now. First of all, you have to know what distance is. Basically, if you go from one point A to another point B, you can take different routes. So you can go along that path 1, you can go along another path 2, and the distances usually will not be the same. But when you talk about displacement, that's the second word, displacement, which is measured in a straight line from the starting point to the finishing point in a particular direction, that is the same as long as you're going from A to B. So even when the distance is not the same, displacement is the same. So that's the second quantity, displacement. In other words, distance is a scalar because it does not have a particular direction. You're going in all kinds of directions. But displacement is a vector. So these are the two types of quantities in physics. A scalar has nothing to do with direction. It only has size. It only has a number attached to it. For example, we might say that the distance is 10 meters. So that's the size. 10 is the size, or it's called the magnitude. So it has the magnitude, and of course this is the unit. So distance is a scalar because it only has magnitude and a unit attached to it. So 10 meters, or it might be 2 miles. But when you talk about displacement, you have to talk about the direction. You have to talk about, okay, the displacement is 7 meters to the west, or to the east, or to the north. You have to specify the direction. So that's what is meant by a vector. So here you have two terms, distance and displacement. And then you have what is called speed. Speed is distance divided by the time. So the time taken to go from A to B. So assuming that this time is like 5 seconds to go from A to B, and if the distance is 10 meters, 5 seconds, you divide 10 by 5. So 10 meter divided by 5 seconds gives you 2 meter per second. So that's how you get the unit of speed. You see, the unit of speed is 2 meter per second. So here you get 2 meter per second. What does that mean? That means you move at the rate of 2 meters every second. Now in the same question, velocity. Velocity is actually displacement over time. So it's displacement divided by time. Now the displacement in our example is 7 meters from A to B because it's a shorter distance displacement in one direction. So you're going to go 7 meter divided by 5 seconds, which is going to give us 1.4 meter per second. So you do notice that the units for distance, speed and velocity are the same. The units are the same. The only difference is you got to say in what direction. So you got to say to the west in this case. So we have 4 words that are very important, 4 technical terms, if you may. Distance, displacement, speed, and velocity. So I hope that's clear now. Let's move on to something really important, which is the last important technical term in this chapter. It's called acceleration. Now, Acceleration is the change in velocity. So for example, in the morning when you start your car, you know you're absolutely not moving. So the velocity at that point is zero because you're not moving. Now that's called the initial velocity. So the velocity at the beginning, it's represented by v sub 0. And that is, in our example, 0 meter per second. It's not always 0 meter per second, but in our example it is. And then you step on the gas, and let's say you're stepping on the gas slowly. So now the car is going to accelerate. And let the final velocity, you have a stopwatch and you are timing yourself. After 10 seconds, you see that you have reached 6 meter per second after 10 seconds. So you're stepping on the gas consistently and the car is accelerating. So the final velocity after 10 seconds is 6 meter per second. See how those terms come in? You have an initial velocity, you have a time involved during which the velocity changes, and you get the final velocity. Now, acceleration is defined as the change in velocity divided by time. Now, change is always final, take away the initial. Change, what do you have at the end? Minus what you had at the beginning, divided by time. So in this case, it's going to be final velocity is 6 meter per second. The initial was 0 meter per second. Divided by the time is 10 seconds, which would give us 6 meter per second, because 6 minus 0 is 0, and then divided by 10 seconds. So you see that the unit now becomes, okay, 6 divided by 10 is 0.6, and the unit is meter per second squared. So that is the unit of acceleration. And I hope you understood what acceleration is. Now, as you're driving, if you step on the brakes, then the velocity is going to decrease, and therefore we would say the acceleration is negative. Now, why is the acceleration negative? Because the car may be moving to the west, but because you're stepping on the brakes, the acceleration is towards the east. Did that make sense? You're stepping on the brake, so it's slowing down. That means the acceleration is towards the east. That's why we say acceleration is negative. Well, basically, if it's slowing down, acceleration is negative. If it's speeding up, acceleration is positive. Okay, though not in all cases, but you can, that is a good starting point. Now, when we go back to this example of the car, let me draw this. So you started from home, maybe at this point A, and assuming that you're moving in a straight line, because you've only been moving for 10 seconds, and you reach B. So that's your, how many meters was that? Oh, so there is one more factor that comes in. Look at that. You have moved through a certain distance. Or in other words, there is a displacement. Let's assume that the displacement is 20 meters. So the initial velocity was 0 meter per second. The final velocity is 6 meter per second. You got to be patient and watch all these terms coming up. And the displacement, how do we represent displacement? It's either delta x or just x. So delta x, all right, means change in x because you moved along the x-axis. And for this, you took a time of 10 seconds. See all that coming in? So there are basically 5 important terms in every equation in this chapter. You're going to have initial velocity, you're going to have a final velocity, You have a displacement, time, and you have the acceleration. See that? These are the 5 terms that appear in all of the kinematic equations. What did I say? Kinematic equations. So what are those kinematic equations? You need not cram them, it's on your formula sheet, but you need to know what each term stands for. So we already got one, which was acceleration is the change in velocity divided by time. You can rearrange this equation and put it like this. It's the same thing. When you do the algebra, you get to the same thing. So you could see it in either way. That's equation number 1. Let's call it 1. Now, equation 2. You don't need to know how to derive these equations, but you need to know this that I'm writing now is the most important equation. Delta x is v naught t plus 1/2 at squared. You know the terms there. Number 3, final velocity squared is equal to initial velocity squared plus 2a delta x. And I'll give you one more that may or may not be on the formula sheet. Delta x is v naught plus vf by 2 multiplied by time. So let's go back over the other previous example that I did, and you remember I finally threw in a displacement there as 20 meters. But let's actually calculate the displacement in that case. What do we know? So whenever you're given a problem, you got to first write down, well, of course, first you have to read the problem, and then you got to write down what's given. So in this case, the question says a car accelerates from rest and reaches a final velocity of 6 meters per second in 10 seconds. Find the displacement. So that is the question. A car accelerates from rest and reaches a velocity of 6 meters per second in 10 seconds. Assuming that the acceleration is constant, which means we are stepping on the gas consistently, you're not hitting it hard. Assuming that the acceleration is constant, A, find the acceleration. Find the acceleration. Okay. B, find the displacement. Find the displacement in 10 seconds. So we want the displacement during the whole journey. So that's what we're going to do here. And we've already worked it out. So you first read the question. Second step, you write down what's given. What's given? Initial velocity, 0 meters per second. How do we know? Because it says started from rest. Second, final velocity. Because it says it reaches a velocity of, that's the final velocity, 6 meters per second. Time is given as 10 seconds. What are you asked to find? The acceleration. Therefore, you write A question mark. So you not only have to write down the terms and the quantities that are given, you also have to write down what you're looking for. In this case, it's acceleration. When you do that and you look at the equations, you are able to make out that you cannot use this one. Why? Because it has no acceleration in it. Can you use this? And you might be like, okay, it has acceleration in it. It's right here. Sure. But do you have all the other terms? No. You do not have the displacement. And so that means there'll be two unknown quantities in that, and that means it won't work. So that will not work either. Out. Will this one work? No, because once again you have two unknown quantities. That's why we're going to make use of this equation. Why? Because you have four quantities, three of them are known, and you're looking for the one that's not known. So let's do that. So now you got the formula. And yes, you got to think about stuff in order to get it. You cannot, it doesn't come automatically. So A is 6 meter per second. This is exactly what we did, 0 meter per second, take away by 10 seconds. And you are going to get 0.6 meter per second squared. So you get the acceleration as 0.6 meter per second squared. So that is the first part of the problem. So now when you get to the B part, you're looking for what? You're looking for the displacement. So when you look for the displacement, you want x. You're looking for x or delta x. Therefore, okay, let me just copy the whole question once again and put it on this fresh page. Come up with some other stuff which I can just get rid of. All right, I'm getting rid of this. So we're looking for displacement now, aren't we? So once again, you start with what are the given terms. Now, V naught is 0 meter per second. Final velocity is given as 6 meter per second. Time is 10 seconds. We did also find the acceleration, didn't we? Yeah, so we can make use of that. So it's 0.6 meter per second squared. So we got that also. So that means we have several options now. You see, we could use different equations. But wait a minute, what are we looking for? We're looking for delta x. Therefore, the equation that we're going to use is delta x is V naught t plus 1/2 at squared. Will anything else work? Yes, it would. But let me show you how we are going to work it out using this. We're looking for delta x. V naught is 0. Time is 10 plus 1/2 times 0.6 times 10 squared. And that 0 times 10, 0 multiplied by anything is 0, plus half times 0.6 times 10 squared. What is 10 squared? 10 squared is 100. So 0.6 times 100 becomes 60. 60 divided by 2 is 30. So in my example, where I took it as 20 meters, I was just throwing in a number. But you see that if you had worked it out, we would have got 30 meters. Now I know that when you do problems like this, since this is the first time ever you're doing physics, it'll seem to be very difficult. But believe me when I say that with practice, it's going to become easier. Do you need some time for that? Of course you do. This is a subject that requires some time. But it's doable, and I've just given you one example. What else do we do in this chapter? In this chapter, we also look at graphs. Basically, position time, velocity time, and acceleration time graphs. So that is chapter 1. Number 1, we need to know all these terms. Initial velocity, final velocity, acceleration, displacement, and time. Then we need to know those equations. And we need to be using those equations to work out problems. Finally, we need to be able to read and draw graphs. 3 types of graphs. Position time, velocity time, and acceleration time graphs. Now, if you watch this video and just say, okay, I got the chapter, you could not be more wrong. You got to watch the videos on YouTube, read the textbook, try to do the problems in this chapter, and you will be good. Thank you. Until the next video, goodbye.